Okay, guys, so this is the last chapter before winter break. So we only have 14 days left. We're going to break this into 3 lessons, and this is the first one. It's going to be very similar to what you've already learned. So let's go ahead and start looking at it. We're doing chapter 8.1. This is over similar polygons. All right, so similar triangles is what we're going to start with, all right? So what we need to make sure that we are aware of is that similar triangles versus congruent. Okay, so congruent means they have the same shape. Oh, that's terrible. The same shape and the same size. So let me get this. So they have the same shape and they are the same size. Okay, so if they are congruent, that means they're identical. All right. Similar is where they have the same shape, but they are a different size. So one will be smaller and one will be larger. Okay. All right. So for similar triangles, the symbol for similarity is the squiggly without the equal signs. So congruent is the squiggly with equals because they're equal to each other. Similar is just a squiggly. All right. So all 3 corresponding angles are congruent. So all of their angles will be exactly the same. And all 3 of their corresponding sides will be proportional, meaning there is a scale factor. There needs to be a scale factor. We talked about this in chapter 4. The scale factor is K, and that will always be your new over your old, your image over your pre-image, all right? So K is our scale factor. I'm going to say this over and over and over. So this tells us how much bigger or smaller the triangle will be. All right, so let's look at some examples. I know on your notes some of the numbers are really hard to read, so hopefully you can see them better here. All right, so just like I did when we were doing congruent, I did 1, 2, 3, 1, 2, 3. I'm doing the same thing here. So this is 1, 2, 3, 1, 2, 3. So angles R and X are going to be my number ones. S and Y are going to be my number twos, and T and Z will be my number threes. So these 2 angles are the same, the twos are the same, the threes are the same. So what are my congruent angles? So angle R is congruent to angle X. Angle S is congruent to angle Y. And angle T is congruent to angle Z. Now, it says write the ratio of the corresponding sides in a statement of proportionality. So this is your original, and this is your, or this one is your new, sorry, this one is your new, this one is your old, okay? So this one is our new one. So we're going to go RT or RS. We'll just go RS. So RS is proportional to XY, side 1, 2, side 1, 2. So RS is proportional to XY. Okay, and that is going to be equal to ST over YZ, which is equal to TR over ZX. Okay, so that is your statement of proportionality. Your statement of proportionality states that these 2 numbers will reduce to be equal to these 2 numbers, and so on. So we do the scale factor from RST, so this is your new figure, to this one, which is your old one. Okay, so new over old. So we're wanting to go from, actually, let me back up. I hope you're using a pencil with an eraser. So they're wanting me to go from here, so to this one. So this one from this one, this is our old, so this is your new, all right? Um, corresponding sides in a statement of proportionality. So in this one, you got to really be careful. Um, these could have been reversed, honestly, because the bottom is your new. So just to keep up with that, I'm going to rewrite this because I don't I don't like that it's backwards. So this is our new, and this is our old. So the proportionality is going to be xy over rs. So xy over rs. Yz over st. So yz over st. And zx over tr. So they're wanting me to change from this one. So if I start here, I'm going to go to here. So this is your new one. So new over old. So that's going to look like new over old, which is going to be, you can pick any side. I'm going to pick 1, 2 over 1, 2. So 12 over 20, and it will reduce. 4 will go into 12 3 times. 4 will go into 20 5 times. So therefore, my scale factor is 3 over 5. And you could check the other sides too. Since I shrunk this, if I go from here to here, you're shrinking, so your scale factor should be less than 1. So you could check 18 over 30. 6 will go in 3 times, 6 will go in 5 times. So notice your scale factor is the same. If you check the other sides, 15 and 25. 15 over 25. 5 will go in 3 times, 5 will go in 5 times. No matter which two sides you compare, as long as you're comparing corresponding sides, you're going to get the same scale factor. Okay? All right. In diagram, triangle DEF is similar to triangle MNP. Find the value of x by using the scale factor. So let's see. Just to stick with it, we're saying that this is our old one and this is the new one. So let's say this is our old one and this is our new one. So I know that D, E, F is 1, 2, 3. D, E, F is 1, 2, 3. M, N, P, M, N, P. And it's super easy when they're turned the same direction, but when they start getting flip-flopped and all that, it's a little harder to tell. So what I'm going to do is I know that 2, 3 is going to go here. So I know that X goes with 30. So I'm going to pair 15 with 18 because they're both the sides that are labeled with a 1 and a 2. So if I do new over old, so 18 over 15, and if I set this up, so 18 goes with 15, 30 goes with X. Okay, and then you're just going to cross multiply. Now, if you get your scale factor first, so if you come down here and you get your scale factor first, I know 3 goes in 6 times, I know 3 goes in 5 times, so you can use your scale factor. So you could do 6 over 5 goes with 30 over X. Okay, or you can just compare the sides. I usually do it this way, but if they're wanting the scale factor, then you reduce first. But just to keep with consistency, so you're going to cross multiply, because anytime you have a proportion, you're going to cross multiply, butterfly method, whatever you learned to call it. So 18 times X is 18X, and 30 times 15 is 450. And then you divide both sides by 18, just like you would any other problem. So now divide by 18, and we get that X is 25. So now I know that this side is 25. So that is how we would go about doing it that way. This way, if you did it, you would get 6X equals 150, and then you would divide by 6, And lo and behold, you would get 25 again. So you can reduce to your scale factor first, or you can just set up your proportion with your sides and do it that way. Either way is okay, doesn't matter. The following triangles are similar. Find the missing side using proportions. All right, so this time they're not telling you like they did, like triangle DEF and all that, but I do see that this has 1 tick mark, this one has 2 tick marks, and this one is going to be my 3. So this has 1, this has 2, so this is my 3. So if I'm going to set up a proportion, then I'm going to compare my sides. So what I notice is the side that has an X is between a 1 and a 3, so that means that X goes with 25. Now 1, 2 is between the 1 and the 2, so that's 8. So I'm going to have to use the number that goes between the 1 and the 2, which is 20 in this case. So cross multiply, 20x equals, and then 25 times 8 is 200. Divide both sides by 20, just like you would any other algebra problem, and x is 10. Sorry about that. So now I know that this side is 10, and that's all you got to do. Just find your missing side using proportions. Proportions are super easy. All right. Oops, I am missing number 4. Number 4, we're going to do it again. So this time I see that they're giving me this piece that's inside here. We have not learned what this piece is called. We will learn that when we get back from Christmas or winter break or whatever we're calling it. So what I do know is that this piece right here, since it's the inside piece, is going to go with the inside piece. So I know that y minus 1 goes with 16. Now I also know that this y is going to go with this 18. So y is going to go with 18. Same exact thing, you're going to cross multiply. So if we cross multiply this way, we get 18 times y minus 1. And then cross multiply this way, we get 16 times y, which is 16y. So now let's distribute. We get 18y minus 18 equals 16y. Going to subtract the 18y. So I'm going to subtract 18y from both sides because I've got them on both sides, so it cancels. So I've got negative 18 equals negative 2y. Divide by negative 2 because I'm multiplying by it. Y is 9. So that would mean that this side was 9, and the inside piece would be 9 minus 1, so this piece would be 8. So if you notice, it's half. 18. 9 is half of 18, 8 is half of 16. So their scale factor would be half. All right, last piece. What is the perimeter? So if I need the perimeter of H and K, so they want the perimeter of the big piece here. All right. So this is a 10, this is an 8. So what I do know is this small triangle, they gave me all 3 sides. So the perimeter of the small triangle is going to be 6 plus 8 plus 10, which is 24. So the perimeter of the large triangle is my x, because I do not know what it is. Okay, so what I'm going to do here is I know that this side right here corresponds with this side right here. So the small base goes with the big base, and that's equal to the small perimeter, which is 24, over the large perimeter, which is x. So now I'm going to cross multiply. 8x equals 240. And then I'm going to divide both sides by 8. So 240 divided by 8 is 30. So now I know that my perimeter, so the perimeter of the large triangle is 30. because their perimeters are also similar. Okay, if their sides are similar, their perimeters will also be similar. You could have found these two sides if you wanted to do two proportions, or just set up your proportion of sides to perimeters. So you got your sides to perimeters. All right, so that should wrap it up. So I will see you guys later. Make sure that you ask any questions that you may have, and I'll see you later. Bye.